Good morning, everybody, or good afternoon, or good evening, depending on where you are. We are here at the headquarters of the ECEM project in Norwich at the University of East Anglia, and we're very proud to be presenting to you this webinar. So I'm going to start now. There's a few people will join us as we go through the slides. If for any reason you cannot see or hear, you can also put a comment on the chat and we'll pick it up and do what is required. But let me start the proceedings with a brief introduction on this webinar, which is about exploring how the climate affects the European energy demand and supply with the new Copernicus Climate Change Service ECEM Demonstrator. And I will explain what all these terms are in a minute. Well, you've seen ECEM at the top, which is European Climatic Energy Mixes. And this is a Copernicus Climate Change Service project, which is developing in close collaboration with the energy sector a demonstrator to assess how well the different energy supply mixes will meet demand over different time horizons, focusing on the role climate has on the mixes. And if you so fancy, you also have a hashtag there that you can use throughout the webinar or indeed after at any time, and provide your feedback or send any message you'd like about what you've seen. So this is just a brief preview of the demonstrator. You will see a lot more in the following talks. I just want to mention that this has been, I think, a great achievement of a very strong team, which is led by UEA, but with strong support and contributions from ADF, University of Reading, Met Office, Armeens, and ENEA, as you can see at the bottom of the slide. And the other achievement is that we started this demonstrator from scratch, so we're very proud that we put this together in consultation with the energy industry and other stakeholders, and we arrived at this stage, which I think it provides a very good and also cutting-edge tool to look at how climate and energy interact with each other. And by the way, my name is Alberto Trocoli, as you can see on the bottom left, right, and I'll be the chair of this meeting. So the agenda, which will run for an hour from 10 UTC about now to 11 UTC, includes 3 talks of roughly 15 minutes each. The first one is combining the science and functionality in a powerful new tool for the energy sector. It's an introduction to the ECEM demonstrator. The second one is a case study based on the understanding of variability of the risk in the energy sector, and is referring specifically to winter 2010. And the third one is enhancing the user experience back to the ECEM demonstrator with some discussion about the documentation and the guidance we provide, which goes alongside all the nice plots you will see. And finally, we have about 15 minutes for question and answer, but if you're interested, you can stick around and we'll continue the session for a little longer, depending on interest. Okay, so a few house rules. As I said, the 3 presentations will be followed by question and answer. So you can type, although you won't be able to speak, unfortunately we can't hear your voice, but you can type your questions in the questions tab on the right hand side. I hope you see that. And then we'll read out the questions at the end, and we'll ask the speakers to address the questions. If you could also point out to who you like to ask the question, then we'll work out more precisely who should answer. The webinar is recorded and will be available online. And lastly, enjoy the webinar. Now I'd like to give the floor, so to speak, to my colleague and work package leader of the ECEM demonstrator, who has overseen the development of the whole demonstrator, Dr. Claire Goodis.
Okay, thank you, Alberto, and it's a pleasure to have this opportunity to be able to present to you on behalf of the whole ECEM team this introduction to the ECEM Demonstrator. I can see the mouse is slightly ahead of me here. Okay, so this is where I will start, and this infographic shows you the different components of the ECEM project that are brought together in the demonstrator. So I think the key thing about the demonstrator is that it brings together consistent climate variables, the variables that are relevant for the energy sector, along with energy variables, and all of these have gone through assessments of quality and reliability. These are available for 3 different time periods: the historical period, so they last about 40 years, seasonal forecasts, so forecast for the coming season, and climate projections going out to the middle or the end of the century. Okay, so as Alberto said, the demonstrator is focused at the energy industry, so practitioners and policymakers, to assess how well different energy supply mixes in Europe will meet demand. I should say the focus is on renewable energy over the 3 different time horizons that I've already mentioned, so from present day through seasonal to long-term decadal planning. And the idea of the demonstrator is that it provides user-friendly and interactive access to an exploration of the climate and energy data produced by the ECEM team. So at the beginning of ECEM, we only had I think a broad first vision of how the demonstrator might look, because we wanted to take a bottom-up approach to its development. So we had some first ideas of how it might look and the types of information might be in it. But at every step of the design process, we've endeavoured to involve stakeholders and potential users. So from our very first stakeholder workshop back in February 2016, when we presented the first vision, through thinking about how the menu structure might be organized, to the first visual tool, to actually getting to the point where we had real data embedded and people could click and actually begin to explore the data. So we hope that through all these steps and through this series of 4 stakeholder workshops, we've got at this point a demonstrator that is already useful and usable and will be used by the energy sector. So we're at the point now where we're preparing for release of a pre-operational phase at the beginning of November 2017. So what you'll see is still work in progress, but I think we've already got a lot of substance to show you. So here is the link to the demonstrator, which is a public link, and what I'm going to do now is actually switch to the demonstrator. So now this page, hopefully you can all see, is how the demonstrator should look the first time that you come to it. So you'll be asked to accept our policy on cookies. You'll be warned that this is still a beta version, it's still a proof of concept. It tells you a little bit about what gives you a welcoming message, and you can take a quick tutorial, but today you've got me with you, so I will take you through, so we can skip that for now. And so what we can see now is the three sort of, well, the map view that we always have on the page, and then around that, the three different panels that give you a lot of flexibility in exploring the data. So we have the main control panel here. We have a help panel here, which provides access to documentation and guidance, and I'm going to talk about that later. So let's just hide that for now. And here we have a legend panel. So, okay, so sorry, the legend panel is in the bottom right, and in the top left we have this the main control panel. This allows you to select the spatial resolution and the temporal resolution of the data that you're looking at. So here we're looking at the country resolution. You can choose the time period that you want to look at. This is not. So I'm having a few problems with the mouse here. Okay, I'm clicking. Okay, sorry, I'm in Alberto's office and he has a fancier mouse than I have. I've got the hang of it now. Okay, so if we click on time period, we can choose the time period that we're looking at. So let's stick with the historical, and we can switch between climate and energy variables, and depending on what we choose, we can see the list of variables that are available. Anything grey is not available currently. So the default view of the map, we're looking at global horizontal irradiance or radiation at the temporal resolution, and we can change that. So for example, we can switch to look at summer. We're looking at absolute values. And as soon as you've chosen enough parameters here, you'll see that your data that you've selected is displayed on the map here. So now we're looking at summer radiation values. So let's move to the bottom right-hand corner, where we have the legend panel, and there's a lot of functionality here in terms of the data that we're looking at. So for example, we can set off the animation. So now we're stepping through. The time slider shows you we're now in the early 1990s. Stepping through, we can step through manually if we prefer. We can stop it whenever we want. If you don't like the default color scale, you can click on this little spanner, and there are a lot of options for choosing another color scheme or for designing your own color scheme. In the demonstrator, wherever you see this little down arrow, this gives you the option to download the data, and it always comes, if you download from the demonstrator, it always comes in CSV format. So that makes it really easy to load into Excel, for example, and do your own analysis. If you want larger data sets and are happy working with NetCDF format, for example, you can also go directly to our FTP site. If you click on this little printer icon right on the right-hand side here, okay, this was working earlier on. we tested it 2 minutes before we started. This gives you, this shows you the map pops up in another window, and that means that you can print the map that you're looking at, or you can cut and paste it into a report. And if you then set up another map, you can compare 2 or even 3 maps side by side. You just need to make sure that you've done what we haven't done, which is to make sure we've allowed pop-ups. Okay, so now let's move back to the main control panel on the top left-hand side, and let's have a look at some energy data. So for energy data, we have demand, this is electricity demand, and we have generation for hydro, wind, and solar. But let's start by looking at demand, and you can choose what units you have, whether it's expressed as energy or power. Let's look at it in terms of energy. Again, we can change the temporal resolution. So let's have a look at summer. And you can look at the demand data with or without the long-term trend. So let's start by looking at it with the long-term trend, although of course that's largely socioeconomically rather than climate-driven. So again, now we can see our maps being refreshed, and we can change this in exactly the same way from the legend panel on the bottom right as we could with climate data. But what I want to show you now is the time series plotting functionality that's always available when you see a map. So if I click on a country, double click on a country, you'll see that a time series map comes up. So this is for France, summer energy demand. Okay, actually I think I don't want to look at the data with the trend. I'd rather look at it without the trend and as normalized anomalies from the long-term mean. So I can change my selection in the control panel and refresh. Now let's do new graph. That gives me a new graph. And I can get rid of that one if I want. And in fact, you can overlay different time series. So for example, I can add another country. Let's look at the UK. I'd just double click on the country. Actually, this time I need to add to graph. So it's now overlain, so now we can see the UK in blue. Actually, I think what I'd like to do now is explore the UK a bit more. So let's forget about France for now. So I can just click there and France will disappear. So sorry to Laurent and others who are online. But also I can take advantage of the fact that we have 2 vertical scales, so I can now plot a series that comes with different units. So for example, I can actually overlay some generation data. So let's look at wind. This is the wind capacity factor, again for the same period. So this is summer, and the generation data is available for a number of different turbine types and using a number of different models. But let's start with this turbine here, and let's start with bias adjusted input data. So the wind that's gone into the model is bias adjusted. And I click add to graph, and you can see that we now have a new vertical axis down the right hand side of the graph. And in green, we can see the wind generation for the UK. If I go to the top right-hand corner of the graph panel and click on these these horizontal lines here, I get a graph menu, which gives me a lot of functionality and control over the graph. So I can I can edit the header. I can change the color of the lines, for example. I have a number of different options for downloading the graphic image, which I can then cut and paste into a report, for example. I can download the data to a CSV file, and I can also plot thresholds on either axis, but let's, for example, plot the zero line for our anomaly data. So now let's go back to the control panel on the left-hand side, and let's have a quick look at the seasonal forecasting data. At the moment, that's just available for climate, for a number of different variables, but let's look at temperature. We have data for 3 different modeling systems, forecasting systems. Let's look at ECMWF system. At the moment, we don't have actual forecasts, but we have information about the skill of the modeling systems. At the moment, we have that in the form of correlations between the forecasts and the observations. And we'll look at an ensemble mean for this particular system. Let's look at summer. So now we can see this has appeared on a map. This is a fixed map. And what I didn't say before is that our seasonal forecasts have a lead time of a month. So this is a month ahead, giving you the forecast for the following summer. You can see that some of these correlations are quite low. So actually I can grey out countries with non-significant skill, just see those countries with skill. In this case, you can see Romania's got the highest skill, and as before with a map, if I double click on a country, I get a time series. So this is for Romania with the observations in blue and the hindcast in red. So now I'd like to go back to the control panel on the top left and have a quick look at climate projections. So going forward into the future, at the moment we just have climate data, but the energy variables will start becoming available fairly soon. Let's start by looking at annual temperature. Let's look at long-term means, and we'll look at the mean of 7 different regional climate models that we have available to us, and we'll look at the highest of the emission scenario that's available to us. So now our maps appeared. This time we just have 2 time slices. So here we're looking at 1981 to 2010, the long-term mean, and we can switch and look at the future, a 30-year period centered on 2050. You can see the map now is much redder, showing the warming. Again, we can look at time series information. Doesn't make much sense to look at time series for long-term means. So let's look at absolute values. Okay, our map has changed. Let's click on a country. Here, Italy, and here we've actually prepared some fairly complex, what we call full projection plots, which we think are a good way of representing some of the uncertainties in the climate projections. So this example, as I say, is for annual temperature for Italy. As you can see, these plots are quite complex. So when I talk later after Emma, I'll talk you through some of the documentation we've produced on these plots. Just to finish off, I'd like to show you an example of the highest spatial and temporal resolutions that we have available. So now you can see I've clicked to clusters right in the top left of the screen, and now we can see 100 cluster subregions across Europe which come from the E-Highway 2050 project. Let's look at one energy variable just to show you that we do have Okay, sorry, I need to go back to historical to show you that we do have historical solar generation available, and now we can choose daily, which is the highest temporal resolution that's ever available. So now our map is showing daily values, and again, if we click on a cluster, so for example this one in southern France, we should eventually get a time series. It's a bit slow. Okay, I think. Okay, yep, we have daily data for southern France. Okay, so that's it from me, and now I'd like to hand over to Emma, who's going to talk to you about the event case studies. So what do you want?
Okay, thank you very much, Claire. That was excellent introduction to the demonstrator. Now we're going to look at some of the features that are probably less evident in the demonstrator, but nonetheless very, very useful. And so I'll hand over to Emma now, who is going to describe to us one specific case study she analyzed, and we'll go through that too. So Emma, over to you, please.
Thank you. Do you have my screen now? Perfect.
Yes, all good.
Okay, so,
thank you.
Cool. So we've seen that the ECEM project has produced nice sets, data sets of historical and seasonal forecasts, climate projections. It's all been put together in this nice demonstrator framework online. And part of my role on this project has been to start exploring that data and to generate case studies using the data and using the demonstrator to sort of start to unpick some interesting events that we can look at using the data that's available to us, the current data that we have, and two, to try and show you how you might start to unpick and generate your own stories, your own case studies using the demonstrator tool and the data that's available on it. So pretty much everything that we do has got these three themes running through it. One of them is understanding variability, so using the historical reanalysis data sets that are available, taking those data sets and doing some sort of analysis of historical variability using pattern-based analysis, looking at things like return times and things like that. Going forward, there's how could you best use the data? Can we anticipate risks for the energy sector, for example, using the seasonal forecasts that are available to us? So how can we make best use of the seasonal forecast data that's out there? And then understanding changes in future risks. So either changes due to future climate change or under future energy systems. And that's all using these climate projection and the future change data that's on the demonstrator as well. So the first role of the case studies is really to show why climate information is valuable and useful in terms of understanding variability and for informing risks for the energy sector. The second role, the second motivation, is basically to show you how you could start using the demonstrator tool. So actually, how can we get best use of the tool itself, the online demonstrator tool, in terms of understanding particular events or understanding changes in risk. And so there's a couple of screenshots here just showing some simple analysis I've started to do, which I'll talk through in a little bit more detail in a minute, but how you can start to really pick through the data and create your own storylines, your own case studies. There we go. So at the end of the project, so there's one case study document that's already available from the online demonstrator tool. I think Claire will show you about some of the documentation after I finish this presentation. But the first case study on the event of the winter 2009-10 is already available on the demonstrator tool. The aim is that there will be several more towards the end of the project and towards the next phase, basically allowing you to sort of see how the data has been used and to sort of start exploring different aspects of the forecast and the data that's available. So there should be several of these kind of documents, and there's still a chance to feed in to any particular case studies that might be of interest. There's still a chance to feed into that and design case studies of our own. So I'm going to step through a case study for winter 2009-10. The reason I'm going to choose this one is because most of the analysis that's been done has been using directly the demonstrated data and tools, so we can start to see how some of the plots that Claire's shown you can be used to tell your own story about a given event. So we can see how the demonstrator tool can be useful for boosting decision making. So I'll give you the headlines now for the winter 2009-10 event, and then we'll step through some of the plots and how I've made them. So winter 2009-10, so that's December, January, February 2009 to 2010, was particularly cold, particularly in Northern Europe. That can be seen using the data in the demonstrator. It was also particularly had a big impact on the energy sector because demand was high for that year. So we saw peak record levels of demand in places like France and in the UK, for example. That can also be seen using the demonstrator tools and the data sets that underlie it. And just to sort of to show you really that the data sets that are available, they bring together credible climate and energy data. So both the climate, underlying climate, and the energy impacts themselves. They've been processed in a consistent way over the whole of Europe. As you've seen, you've got that whole map of Europe to look at. And they cover the range of timescales and resolutions. So we can really start to unpick certain types of questions. We can look at dependencies in risk across Europe, if that's the kind of question you're interested in. You can put a particular event into the context of recent history, or we can start to ask what-if questions. So with the historical reanalysis that's on the demonstrator, we can start to look at things like the energy variables themselves, the wind power capacity factors, hydro power capacity, for example, and we can start to ask in the context of today's energy mix, how would a case like winter 2009-10 have looked based on today's energy mix, which I think is a really useful kind of question to be able to ask. And then we can use the seasonal forecast and the climate projection data to try and anticipate future risks. So using the demonstrator tool then and clicking through some of the plots, we can start to see, for example, then in 2010, so December 2009 to January, February 2010, we can see that in the UK, so this blue line on this and the left-hand plot here, so in the UK, we're looking at absolute values of electricity demand. So this is modeled over the historical period of 1979 to the present day. And we can see that in the sort of 2009-10 winter, so this is winter time, 3 monthly average data, there was a peak in demand for that time, and the same in France. So we had record levels of winter mean demand over those two countries, and over many northern European countries there was very high demand compared to history. And if we can start unpicking that, so this is 3 monthly averages, we can start picking into the data and going into a finer temporal resolution into the daily data, and we can see that there's compared to normal, so 0 would be your average baseline demand. We can see that over the whole winter period, demand was higher than the average, and there are these several big peaks, particularly in France, which has so this is as I said, modeled electricity demand, and we know that France has a higher percentage of electricity in its generation mix. So we see these big peaks over the winter period between December and February of 2009-10. So we can start to pick into the data, and we can start to ask the questions of what's going on here. We also know that that particular winter was particularly cold. So again, if we look at the map on the left-hand side now, we can see this is anomaly data. So over the historical period, these are anomalies relative to to the full historical period. We're looking at a seasonal mean, so December, January, February, for air temperature. And we see that for 2010, we get this colder than average conditions over most of Northern Europe, and a very sort of sharp gradient of temperatures. So cold in the north, warming up down in the south. So we see a sort of north-south divide in terms of temperature. It was very particularly cold for the season in that particular year. And we know from this, I mean, this case has been well studied from a meteorological perspective. We know that that's consistent with a persistent negative North Atlantic oscillation pattern. So that's sort of consistent with what we might expect from what was going on in the oceans and the atmospheres at the time. We can see in terms of, so we can pick into the time series, as Claire showed us before. We can actually click on the UK and on France, and we can show those winter mean temperatures. And we see that for the UK, for example, it was one of the coldest, or is the coldest winter in recent history in terms of temperature. And for France, it's still one of the coldest. So we can just draw a line and show that it's within the bottom 20% of winters over the recent historical period. So again, we can start to see that how that plays out in the demonstrator tool. So this is all using demonstrator data. If we download the data, temperature data and the demand data, we can start to do some simple analysis. So this is a plot made just reading the CSV file into Excel, making a simple scatter plot and looking at the correlation between temperature and power demand. And we can see that the two are strongly correlated. So again, we can start to do simple analysis, scatter plots of temperatures or demands across different countries in Europe, or across different variables. So we could look at wind power and demand, for example, and start to play around and do some simple analysis just using the data that's downloaded, and we can start to ask those kinds of questions. So we can see that when we know that there's a strong correlation between temperature and demand, and this is particularly over the UK. Again, so we can ask the question, what if? Using the historical reanalysis, we can start to say, okay, what if winter 2009-10 happened today based on today's energy mix? So this is a plot showing wind power capacity factors based on today's energy mix, so today's available capacity of wind power. And we see that the winter of 2009-10 was particularly low wind, again consistent with this negative North Atlantic oscillation pattern. And we see that if that happened again today, based on today's energy mix, we would see record lows in wind power capacity factor. So that might cause a problem for the system. So we might know that there's a high risk associated with that kind of winter happening on today's energy mix. We can also start to say, well, can we anticipate these cold spells and what impacts they might have? So it's all very well to know that what it might look like if it happened today, but can we anticipate that? So there's two ways we can do that. We can think about the seasonal forecast or the climate projections. Looking at the climate projections then, if we look at the data from the, so this is just the model mean, so the multi-model ensemble mean from all the different climate models that have been run from present day out to 2100, looking at the winter mean air temperature. And we can see that there's a general upward trend in winter mean temperatures. So we might say, okay, that's kind of good to know. We might expect fewer very cold winters going forward into the future based on these scenarios, based on the data that we can see here. In wind power, so I haven't plotted the wind power, but there is no trend in wind power. So it could be equally likely that we could see very low wind generation or very high wind generation. There doesn't seem to be any kind of upward or downward trend in the data, but we do see temperature. It might be less likely that we would get a very cold winter like the 2009-10. So that's one way we can start to use the projection data and ask questions about how we might anticipate risks going forward. Okay, so as I said, the seasonal forecasting, this is going to be, there's going to be a whole separate case study on this a little bit later on, which I'm in the process of putting together now. But basically, we can start to click through the demonstrator tool as well and start to ask, can we use the seasonal forecasting systems to anticipate the next winter, for example? So as Claire said at the minute, basically what you can look at is the how historical seasonal forecasts have performed compared to observations. So we're looking at correlations rather than actual forecast data. We're starting to ask, can we actually do this? Are the models skillful enough for us to do this for our variable and our temporal resolution of choice? So for example, if we look at the climate air temperature variable from ECMWF's System 4 model, we can start to look at the correlation score, plotting only what's significant. And we see that in the winter, there are significant correlations over the UK and over this region of Northern Europe here. So we could say that we might trust the seasonal forecasts for these regions. There are words of caution, however. There's not significant skill everywhere. So parts of sort of Western Europe, so Southern Europe, France and Spain, for example, don't happen to show correlations for this particular model. So there are some words of caution for using and looking at the data, but we do have some hope given the levels of skill that we can see. So there are different skill metrics available to sort of explore on the demonstrator tool for that, or at least there will be. So in terms of other case studies going forward, then just to quickly mention, there will be one specifically on the seasonal forecasting aspect, because it's slightly different from the projections and the historical data, historical reanalysis data. So there will be a specific case study based on this. So one picking into regions of skill. So this is an example where we can see June, July, August temperature. Happens to be there's a lot of skill down here in the kind of Balkans region, and if you start to unpick that, we could start to say, okay, well, we trust the seasonal forecasts here across multiple models and across multiple skill metrics. So that might be a way we can start to unpick to use the seasonal forecast data, for example. We also know that there's from other studies that there's skill in predicting larger scale patterns, so things that are happening in the North Atlantic, for example. Something called the North Atlantic Oscillation Index. There is skill in predicting that metric, so there might be ways that we could take that metric and directly push that into understanding the climate variables and the energy variables directly. So using the large scale meteorology that's happening and the large scale drivers to actually then start to say something useful about energy impacts directly. And then, so just a quick mention that some of the other case studies going forward are going to be more broadly based around just understanding variability using the historical reanalysis data. So looking at dependencies across countries and across variables, for example, and then starting to dig into some of those large-scale patterns and how they could impact variability and skill over the historical periods. So just to summarize then, so the current case studies that we're looking at is the winter 2010. So I've chosen that one because most of the data for that one can be used by clicking through the demonstrator. So it's a nice way of showing you how you can start to create your own stories using the demonstrator tool. There will be one on seasonal forecasting, which is under development, and on the climate projections itself, and then a broader, wider technical report, just trying to unpick some of this data looking at historical variability. We are open to suggestions for other case studies. So if you have a particular event that you knew was a particular risk or a particular vulnerability for the energy sector for your country or for your your favorite energy generation. Energy generation. Then we're open to suggestions for other case studies that might be warrant looking into as well. So that's just a plug for that. But this is just to summarize basically, so that the demonstrator tool is useful. You can start to see how by clicking through some of these options, you can start to create your own case studies, boost your own decision making. But obviously, using both energy and climate data. But obviously, there are still cautions to be had with that as well. But there's various different questions we can start to ask. I think I will leave it there. Thank you.
Okay, Emma, thank you very much for your very clear presentation and very useful to show what can be done with the ECEM demonstrator. We might have already mentioned that this is a proof of concept exercise. So we are trying to explore what we can do, but there's obviously much more that can be done over the next months and years, hopefully. So we're going now back to Claire, who will now tell us about the documentation on the ECEM Demonstrator. Over to you, Claire.
Okay, thank you, Alberto, and I'll try and go through this fairly quickly so we have time for questions. But in fact, I think we've already had one question about documentation, so at least that will be answered. So as I say, I'm going to quickly take you through some of the different strands and levels of documentation and guidance that we have embedded in the demonstrator, and we're still working on and adding to all the time. So this comes in the form of pop-up boxes, of links to PDFs, of links to other websites, as you can see from your your first visit to the demonstrator. So right from the beginning, we're getting little snippets of information, and on your first visit, you get the opportunity to have a quick tutorial, which essentially takes you around some of the functionality that I showed you earlier on. We also have more detailed information available from the main help menu, which is this one in the bottom left-hand corner. And I'm going to start just by clicking on the About button. This tells you something about the software underlying the demonstrator. It also gives you access to the tutorials, but importantly, it also tells you the version number of the demonstrator that you're looking at, and the date, and the changes from the previous version. So I think that's really quite important, particularly in the lead up to the pre-operational system in November. So you always know which version of the system you've been working with. If you want to know more about the functionality than you get from the quick tutorials, you can go to this section on using the demonstrator, which tells you a lot more, for example, about how to view and download the data, so showing you more of the functionality that I showed you earlier. I won't go through that now, but again, in response to one of the questions, which I think was essentially asking about sort of metadata, the provenance and the processing of the data that you see. At the moment, that's the sort of primary source where that information is provided are in these variable fact sheets, and you can access them either by clicking in the control panel on the question mark next to the variable name, or you can come down to the help panel, click on variable fact sheets, and there you can see the full list of 7 variable fact sheets for the climate variables and 4 for the energy variables. So for example, if I click on the one for wind speed, all of them have a standard layout, so the kind of information that you would expect to see in terms of metadata. So information about the temporal and spatial scales, some brief information about the processing, information about the units, and it also gives you links to the original source of the data. So the idea is to be as transparent as we possibly can, and it also includes information on the 3 different timescales. So here, for example, we see information about the historical wind data, the seasonal forecast wind data, and the climate projection data. Okay, I want to close the. Okay, I want to close the PDF. That's hidden by. Okay. Okay, but as I say, the variable fact sheets give you sort of fairly technical information. It may be that you're completely new for working with climate data or with working with climate projections. So in this product overview section, in the methods and assumptions, we've tried to ask some fairly general questions and give fairly brief answers to some sort of first questions that you might have. For example, what are the regional climate model ensembles that I showed you earlier? So relatively brief replies there. In this second part of the methods and assumptions, we've got to the stage of identifying the topics and some of the questions that should be there, but not yet written the text for them. So these relate to sort of broader questions about confidence and uncertainty in our data sets, skill and reliability. So really moving on to thinking about issues that are important to consider when you're actually using or applying the data in sort of real-world situations. And although those haven't actually been written yet, as you've seen, we already are building up some examples of showing you how the data can be used in case studies. And shortly we'll be adding some further case studies, or Emma will be adding some further case studies to the one that she presented to you just now. We also have this section on key messages and pre-prepared graphs. So the idea of the key messages is that they're based on the data that's embedded within the demonstrator. We've got a couple of examples so far. So let's look at this one. And these are very deliberately kept to 2 pages, but also have a summary in a few bullet points of the key messages. So this one is looking at the temperature projections across Europe, and just sort of noting in general terms the implications for the energy sector, where subsequent key messages will focus more on issues such as this, on exactly how these temperature projections will impact on energy demand in the future, as well as solar and hydro supply, because temperature is one of the input variables that's used to calculate this generation data. Now, as you can see, this key message includes an example of those complex projection plots, and I told you that we had we'd I've closed the wrong thing. Okay, yeah. I told you that we'd prepared some documentation on those plots. So if you come to this pre-prepared graph section, what we're going to do here is provide information about where we've provided sort of standard plots. So I think later on we'll provide some information about the seasonal forecast time series plots, for example. But this one is on the climate projection plots. So it kind of explains to you briefly why we deliberately chose to present the data like this. It gives you an example. This is annual temperature for France. And then it kind of goes through looking at the individual components that are sort of plotted on here and explains why, and something about the informational content. So for reasons of time, I leave you to go away and read that on your own. And I will just finish off by pointing you to the FAQs section, which at the moment has 3 sort of more operational administrative questions that we thought might be useful for you. But this is an area where we really want to build input based on responses and comments from our users. And for example, I think that some of the questions that you asked today, will subsequently write those up as FAQs. Also, feel free over the coming months to suggest additional topics. And on the far right-hand side, the edge of the demonstrator, just above the link to the FTP site that I showed you, there's a link to feedback which takes you to a Google form, so please do use that. But now it's over to you, and we will go through the questions that you've been asking us. So thank you.
Okay, thank you very much, Claire. So we have indeed some questions that we received, and we are going to quickly type them onto a spreadsheet or actually a PowerPoint presentation so that we can show them to you, and then we obviously address them. And as Claire said, we also keep those, or some of them, for the FAQ section in the demonstrator. So thank you again for the questions. We have 5 minutes left, but we'll probably go a bit over. I hope you can stay with us and listen to just 6 questions. Some are repeated actually, and then we'll wrap up very briefly. So I'd like to go through some of the questions quickly. Some have been addressed, like the first one, temporal resolution, we said is 1 day. Maybe Claire can respond to the last one, which is related to the number 1, and I'm going to show you the question now. Okay, so you should be able to see the questions.
Yeah, so as Alberto said, within the demonstrator, the minimal temporal resolution is daily. Having said that, in fact, in some cases 3-hourly climate data, so for example wind or radiation data, is used to compute some of the energy variables, although the energy variables are still only presented at a highest resolution of daily. One of the reasons why we chose to somewhat limit both the spatial and the temporal resolution of the data to daily and the cluster level is because we see one of the key advantages and strengths of the demonstrator being the fact that it provides consistent information across the whole of Europe. And that somewhat restricts the availability of input data that we have. But I think right from our very first workshop, the question of resolution came up, so we're very much aware of it. We're already having discussions with the wider Copernicus Climate Services system about provision of high resolution data, and it's something I think that as we go into forward into the future, perhaps after the ECEM project, in a future operational system, is something that we will come back and see if we can improve the resolution.
Okay, thank you, Claire. I see the questions ramping up now, so we won't be able to address them all. And actually, we also have Emma, who talked about the case study, and also the developer of the ECEM demonstrator, Barbara, online. So feel free to jump in if you like. We're trying to be as expedite as possible now to address the questions. There are a few questions that I can actually address. So like our demand and generation gross or net values. We said that they're both actually, so that we provide, we always try to provide both the full values and the anomalies. But if that's what is meant by net value, so net values would, I guess, requires a bit more explanation. But I would like to refer you to another webinar that is coming up on energy variables, or address the question directly to us. We'd like to keep the questions for today mainly to those related to the demonstrator itself, and that applies also to the geographical scale of the data. How do you transform the temperature in demand? Particularly, this question is done with statistical models. So just a brief answer on that. But again, if you get back to us, we have the documentation. We can provide more expanded answers to those. And actually, as I said, we'll try to convert these questions into FAQs to the demonstrator very soon. there was another question also about availability of climate projections for energy, and these are actually being computed as we speak, and the target is to have them available by the end of October. So watch this space. I don't know whether Claire wants to address the question about documentation on data available. So you already said a bit about the variable fact sheets.
Yeah, I think that's the most important source of information on those specific questions. But then we also have broader information about the comments about how to use the data, for example, when it's appropriate to use an ensemble average, when it's not so appropriate. So again, we're trying to provide information at kind of different levels, some technical, some less technical, and aimed at sort of different types of users. I can see there are a couple of questions about the ERA 5, so the new reanalysis data that ECMWF is producing. Of course, we're very aware of this. And this will help to address some of the resolution problems. We hope that it will also give us so that some of the variables, so for example 100-meter wind speed, will be more reliable in ERA 5. It's not something that we're going to be able to incorporate in the pre-operational version of the demonstrator, but it's definitely something for a future operational system.
Okay, so I think we addressed most of the questions. There's one left on the what we expect to have a seasonal forecast in real time. So there is this is actually not happening in the space of the ECEM project, which by the way is going to end in January 2018 most likely. But there'll be follow-ups to this project most likely. And whatever shape the seasonal forecast will be available then on those follow-up projects. And in fact, the seasonal forecasts are becoming available right now through the C3S seasonal stream of products. So they're not quite in the format that we would like to have them at the stage, but we are able nonetheless to look at them and provide the skill measures that Claire also mentioned, and Emma also showed in some part of her talk. And if you look at the demonstrator, we actually uploaded very recently new variables. So we encourage you to play around with the demonstrator. And by the way, you'll have seen, you'll have noticed perhaps that the demonstrator was a bit slow when we were showing it to you. Of course, we are going through the net and so on. It's going to be much faster when you access it. You might have done it while we were talking, so you know what I'm talking about. So that's basically the last question, except for the out of curiosity. We can add the out of curiosity there with how many people follow the webinar. So at the moment there are 34 of us online. We had actually, it's typical of this webinars, roughly twice as many people register, and those people will likely get the message. Well, they will get the message, and likely they will connect and look at the recording afterwards. So thank you also to other people who have registered but couldn't attend. I know the constraints, time constraints, but thank you very much to those who have attended. So I'd like to just wrap up now and go through the one last slide, which is about upcoming ECEM webinars. We have 3 other webinars scheduled for you. The first one has a date, which is the 18th of October, and it's going to be about the climate data. So we talk about the quality, where the source of the data, and what you can do also with the demonstrator or with the climate data that is loaded on the demonstrator. And a similar talk but on the energy data will be given on in November. We have to define the date yet. And then because we are in a full phase of development still with the demonstrator, we thought that that, we'll come back to you with a similar talk of today, but with updates, so hopefully much more data, so like including energy data and several other features. So that will happen in December. So please keep an eye on the ECEM website, which is given here, as well as playing with the demonstrator. And there's a feedback form that you can fill in on there's a tab on the right-hand side of the demonstrator. Feel free to fill it in and click send with some comments that you may have on the demonstrator. And with that, I would like to again thank you for your participation. Thank all the speakers that have given this excellent talks, Claire, Emma, and thank you, Barbara, also for being here with us and developing this very nice demonstrator, as well as all the team behind the ECEM project. Thank you very much, everybody.